welcome to
Winnie and Alice
Presents
Keeping
Up with the IB Biologist. Yay.
Yay, I don't know why I look like a sewer person. What is wrong with my hair?
It's okay, that's who you are. Stop hiding.
Okay.
So today we're going to talk about the
Plasma membrane.
which is very, very important. And our last video was about the cell structure, so you can link those stuff together and practice.
Practice makes perfect.
So as we just said, we're talking about the plasma membrane today, or called the cell membrane if you're still in grade 10 or grade 9. So there will be a brief, very short introduction first, and then we'll be talking about the phospholipid bilayer, and then the fluid mosaic model, which is about the structure, and then a whole overview of the functions of the plasma membrane, and then we'll be talking about its selective permeability, and then the most important part is the cellular transport, but that will just be an overview, because if we're going to talk about the proteins and stuff on the membrane, that will make the video super long, so that will be in another separate video only for those plasma membrane proteins. And the last one will be cell adhesion.
Okay, so the plasma membrane is very important for obvious reasons because it separates what's not the cell from what is the cell. It separates the intracellular environment and the extracellular environment. Now, it is a selectively permeable barrier, which we'll get into more in depth later. And besides all of these functions, it also has another series of functions that has to do with cell signaling, adhesion, and transport processes, all of which we will cover later.
Yay! So now we're going on to the phospholipid bilayer. So the plasma membrane is composed of a lipid bilayer.
Oh, Winnie! What does bilayer mean?
Well, literally bi means two, so there are two layers of the phospholipids.
That makes so much sense.
I know, right? Okay, so the lipid bilayer consists of phospholipids, cholesterol, and some membrane proteins. So these will be included, and will be explained more detailed in another video, only for membrane proteins, right? Yeah, okay. So phospholipids form the main structure of the whole membrane, while cholesterol provides stability and fluidity. So proteins are embedded in the lipid bilayer and have diverse functions. So the bilayer is called a bilayer, not just because there are two layers, also because there are separate regions. One of them are the hydrophobic and also hydrophilic. So the hydrophobic part is
the hydrophobic core.
Yes. So where is the hydrophobic core?
In the middle.
Right here. So you can see those two tail thingy for each of the phospholipids. They're called the fatty acid chains or the fatty acid tails. So they are hydrophobic, and because it's a bilayer, and the two hydrophobic regions, they're together and form the hydrophobic core. And as we know that they're both hydrophobic and hydrophilic parts, and now we know that the fatty acid tails are hydrophobic, so the hydrophilic part is the
hydrophilic head.
Yes, right here, that cute little circle, which face outside the membrane and also inside inside the cell.
But Winnie, wait. Part of the phospholipid is hydrophobic and part of it is hydrophilic. So what should I call it?
So for stuff like this that has both hydrophobic and hydrophilic parts, so that means that they have both what? Polar and nonpolar regions. So the word is amphipathic. I'll put it here. Okay, so the word is amphipathic to describe stuff like this.
Spelling this right.
No one cares. Okay, so you have to know. That's all you have to know about the bilayer for now.
We'll put the correct spelling there later.
Yes, good. Alice is obviously not good at English.
Yeah, obviously. I'm not a native speaker. Now, I'm going to introduce to you the fluid mosaic model. So the fluid mosaic model is a model for the plasma membrane that describes the dynamic nature of the plasma membrane. So it suggests that the components of the plasma membrane are not fixed, so they can move around either laterally or vertically. So we know that molecules, particles, they diffuse around, right? And phospholipids, they are molecules too, so of course they're going to diffuse around as well. And there are two kinds of movement. So you can either have vertical movement, where this phospholipid, it just kind of moves up and down, just kind of drifts around, but it doesn't leave the membrane because it's attracted to the hydrophilic parts, right? You have those hydrogen bonds in your polar parts. But it does kind of move up and down a little, so you have vertical movement. And the other kind of movement is called flip-flopping, like just like that. So it goes top to bottom, bottom to top, and you flip-flop. And flip-flopping is very, very rare. And what does the mosaic part of the fluid mosaic model mean? Well, basically, it's describing the proteins on the model. So our membrane moves around and it's embedded with an array of different membrane proteins, which we will go more in depth into later. So this dynamic arrangement allows for the flexibility and functionability of the plasma membrane.
Yeah. So now we are moving on to the important part of this video, which is the functions of the plasma membrane.
But it's only an overview, so don't expect details.
Yes. Fine. Well, once again, more detailed stuff will be in another video, okay? So please check that video to make sure you know other things. Okay, so first, the plasma membrane has several important functions. First of all, selective permeability.
Yeah.
So this controls the entry and the exit of substances to maintain cellular homeostasis. Do you know what homeostasis is?
No, how would I know? Oh my god.
Me neither. No one cares. Okay. And the second...
Wait, what? You should define homeostasis.
What I should.
Yes. What is homeostasis, Winnie?
It is a stuff that keeps you balanced. What? How to define it?
Maintaining a constant environment within the organism.
Maintain what constant environment?
For homeostasis is the maintenance of a constant environment.
Biotime. Okay. Check it yourself. You have Google.
Wait, what?
Okay. Winnie, if you're editing this, remember to add homeostasis definition here. Okay, good. Okay, so next one is the cell signaling and communication. So, this mainly describes the function of the plasma membrane, which receives and transmits signals to coordinate cellular activities. And third is the cell adhesion, which we all know that enables cells to adhere to one another from tissues.
What does adhere mean?
Sarah's like,
Yeah.
serious. Like,
Yeah.
adhere means like, you get it? If you don't,
Then.
okay, so the last one is cellular transport, so which facilitates the movement of the molecules and ions across the plasma membrane. And that's all.
Now to the important part, selective permeability. We have mentioned this before. What does selective mean? It means it only lets some particles through. What does permeability mean? It means it lets stuff through. Now, the plasma membrane is selectively permeable, meaning it only allows certain substances to pass through while restricting others. How does the membrane achieve selective permeability? Basically, the hydrophobic core, so this part, blocks molecules out. What kind of molecules? Polar molecules and charged ions. Also big ones because you just can't get between those little spaces. Why? Because hydrophobic parts don't repel hydrophilic parts, but hydrophilic parts would attract each other due to the hydrogen bonds. So if a polar molecule were to exist in the extracellular environment, which is aqueous, then it will be strongly attracted by the water molecules because of the hydrogen bonds. So it wouldn't be attracted by the hydrophobic core, not repelled, but not attracted. So it's attracted here, but not here. So it wouldn't be likely to diffuse all the way through, which is why the membrane is permeable to small nonpolar molecules. So small and nonpolar, like oxygen or carbon dioxide.
Don't
And
treat your audiences like idiot, Alice.
Are you an idiot? I'm sorry.
What?
I'm sorry. Okay.
Cancel, subscribe. Do not subscribe.
Oh my god, don't. I'm sorry. I love you. You're so smart.
Go on.
Okay. Larger molecules, like, for example,
Me.
yeah. They wouldn't fit through these spaces, right? They wouldn't fit between the phospholipids and the aforementioned charged ions and the polar molecules. So they would be blocked out by our good old hydrophobic core. And that's selective permeability for ya.
About cellular transport first is that a thing that we know, like I literally don't know why Alice add this to our content. Diffusion. Define diffusion.
Yeah.
You're wrong. Okay, so diffusion is the passive movement of molecules from an area of high concentration to an area of
Low concentration.
low concentration.
Also, you're missing a word.
And the differences between those concentrations are called concentration gradient.
You're missing a word. The what movement?
The net movement.
Yes. Remember, it's net movement.
Define.
One single molecule can move from low concentration to high concentration, but the net movement of molecules is always from high to
Okay,
low.
we know you're smart. Shut up. I'm sorry. Okay, so second, also a very
You can dance to that. That means midnight snacks are going to drop from the sky.
okay. And the second one, also a very common thing. Why did you put that in? No one knows. Okay.
What did I put?
Osmosis.
What's osmosis? Never heard of it
Osmosis is the diffusion or the movement of water across, listen, across a semi or partially or selectively permeable membrane. Remember, it is the movement of water. There has to be a membrane, and the membrane is partially permeable. And now you master biology.
before. Wait, does diffusion need a membrane?
Of course not. Like, if you fart, I can smell it right now.
Okay.
Okay, so third, facilitated diffusion. Okay, this is like obviously more useful than the others, or like more to understand than the others. Like, yeah.
Like.
Yeah, okay. So facilitated diffusion is the passive transport of molecules using specific carrier or channel proteins, which you will see in our next video. Okay, so active transport, the word active means it does not just move by itself. Okay.
It requires
What? Energy. Great. So active transport requires energy to move molecules against their concentration gradient. And that means molecules move from an area of low concentration gradient to an area of high concentration gradient. Great. No gradient. Okay, whatever. From low concentration area to a high concentration area.
Yeah.
Okay. The last one is endocytosis and exocytosis, or as you might know them as the Hulk transport. Yes, Hulk. We love Hulk.
Basically, the Hulk lugging stuff around.
Very good. So Hulk transport, the processes involve the engulfment or release of substances by the membrane. Okay, pop quiz. Define osmosis. Wrong. Define facilitated diffusion. Wrong. Tell me one protein pump. Wrong. It will be in our next video. Check it, please. Okay.
Now to our final one, cell adhesion. What is cell adhesion? Basically, a cell sticking to another cell. And cell adhesion is essential for maintaining tissue integrity and facilitating cell interactions. So, the plasma membrane contains cell adhesion molecules called CAMs that allow cells to stick together. And CAMs are involved in processes like embryonic development, wound healing, and immune responses. And the only two types of cell adhesion we really have to know would be the tight junction and the gap junction. The tight junction is basically when two cells are stuck together tightly, so nothing can pass between them. And the gap junction is when there's a gap between the cells. So
I have a question.
Sure.
Are there any gap junctions in plant cells?
Yes, the gap junction in the plant cell would be called the plasmodesmata, which I also don't know how to spell. Sorry. We'll put the spelling here later somewhere. Okay, this is ugly, but basically, ta-da! Here is the gap junction. Basically this, a gap between the two cells. In plant cells, it's called the plasmodesmata, so it allows substance exchange between the two cells without having to pass through a membrane. It also counts as cell adhesion.
Yay!
Yay! We're done! In this day and age, before the midterms, we're all insane. This is what the world has come to.
Shut up.
This is the best you'll get.
Shut up.
Shut up, I'm going to cry. I'm going to cry as well.
Jinx.
What are you going to do about the midterms?
I don't care. I hate biology.
Oh my god, don't say that! Don't say that, Winnie! What if the kids hear you?
I swear, I love biology.
Yes, we all love biology.
But I'm still going to get a 3 in midterm.
That's a lie, and we know it.
No, it's not. No, it's
He
not.
always says that and then gets a 7.
I never get a 7.
Yes, you do.
And also, by the way, I'm super hungry right now. I want to go to eat 宵夜.
Me too. No one's gonna understand that, you know.
Okay, what the hell is 宵夜in
Wait,
English?
wait.
YouTube, please translate that.
I don't know, midnight snacks or something?
Wait, they're actually called midnight snacks?
No, midnight snacks are snacks at midnight. It's literally like 10 o'clock.
For non-Chinese people watching this, 宵夜 spelled as Xiaoye. Go search it.
Yes, it's basically eating at 10.
Or 12.
Or
Or
10.
anytime.
Yeah.
Between your lunch, dinner and breakfast.
Yes.
Check our next video!
It's gonna be better, we promise.
And it's... Oh my god, what is
Oh
this?
my god! I can't believe you're wasting your time watching us do this. And you're not doing your homework.
I'm
and you're not
sorry, but we
learning.
love you, and we're going to eat 宵夜 right now. Goodbye.
Yeah, we love you, but go study. We're gonna go eat, so.
Bye. 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 Bye.
Bye.
Bye.
Bye.
Bye. Bye. Jinx.
Okay.
Wait.
It's 10, there's no food.
The horror music.
That means there's no food.
Ghosts.
That means the apocalypse is here.
That is literally one of the longest videos.
Literally.
Bye.
Bye. Bye.
Bye.